The urban heat island effect. Here you see the visuals of rapid urbanization. The natural landscapes are replaced by the dense infrastructure, disrupting the ecological balance. The cities become significantly hotter, while their neighborhood villages stay at cooler temperatures. This leads to a higher heat concentration in the urban areas compared to the rural neighborhoods, and this phenomenon is called the urban heat island effect. The UHI is caused by several factors, some of which are uncontrollable and some controllable. While we can't change the climate or topography of a place, but we can definitely address the controllable factors such as urban design and socio-urban parameters. Eliminating these man-made causes will lead us to mitigating UHI. UHI is not just about discomfort, it's a silent threat posing numerous health and economic losses. For instance, 45% increase in mortality risk is estimated due to UHI, and about 1.5% reduction in GDP is seen due to UHI and global warming. So it's time to end this heat strife and move towards a cooler, sustainable, and resilient urban future. So here we are introducing our geointelligence solution for UHI detection and mitigation framework. We have designed a remote sensing technology leveraging satellite imagery and machine learning techniques to analyze and predict the UHI indices, which is a quantification factor for urban heat island effect, and to identify the causes contributing to UHI, and recommend mitigation strategies using LLM. So how do we do it? We start with data acquisition, wherein for each input place, we extract the satellite imagery, its environmental factors from the Sentinel satellite through Google Earth Engine, and we also extract few socio-urban features which are related to UHI. We then apply data pre-processing techniques to convert this satellite image into more usable format, and we apply semantic segmentation techniques to have a pixel-wise classification of the satellite image into one of the 9 classes such as water, trees, crops, etc. And we have a 3-staged modeling layer where the autoencoder model with regression modeling will give us the UHI index prediction, and the random forest classifier will give us the UHI cause classification as man-made or natural. And we have an ensemble regression model of RFR, SVR, and LGBM to have a 12-month UHI index regression. This way, we can analyze the UHI indices of a place throughout the year. And if it is a heat island which is caused by man, we give mitigation strategy recommendation using LLM. So without any further ado, let's see it live in action.
So let's dive into the demo. The first thing the user is prompted to do is to input his region of interest. So I'll pin Philadelphia. So once the input is given, the geospatial coordinates of the particular region of interest is retrieved, and from there the Google Earth Engine generates a set of features that will be needed for analyzing UHI. Once the extraction of all the required features is done, the user is presented with a dashboard where he can view information about his ROI. The satellite image captured is about 10 km² in area. The user can dwell more into these options. So let's dwell into socio-urban features of Philadelphia. UHI depends on a variety of factors, one set of them being the socio-urban features. These socio-urban features give us a picture about important parameters such as urbanization, population, and industrial emissions of that particular area. Therefore, this web application helps users analyze the socio-urban factors of their region of interest. The user can also analyze 15 satellite features that have been extracted using the Sentinel satellite. So the user is provided with the information regarding that particular sentinel index, its use, the bands that are used to calculate it, and the range throughout which this index appears on the region of interest. So the user can also view his choice of sentinel index with the best suited color palette. So NDWI, I will choose plasma and generate the plot. So here we can visualize the selected index with the selected color palette most suitable for it. Proceeding to the main agenda of this work, here we discuss about the urban heat island index of the region of interest. Firstly, we determine the land use land cover of the region of interest using the UNET model. Using the combination of all features discussed and this LULC, a 12-month trend for the region of interest is forecasted using an ensemble of RFR, SVR, and LGBM. Additionally, the cause behind the urban heat island is classified as natural or man-made, and if man-made, we offer LLM mitigation strategies. Additionally, an overview on how sentinel and socio-urban features vary across the world is displayed here. So the user can select any index and any value which he wants to analyze across the world and submit to view it. So this is the way we can view how each value varies across the world. In summary, our work provides a globally scalable solution by harnessing remote sensing technology. A detailed analysis is done on various features such as sentinel, socio-urban, and LULC. The variation of UHI across different seasons is forecasted, hence providing an innovative approach to analyze UHIs. LLMs are also being utilized to tackle UHIs and hence provide sustainable urban planning. Additionally, an overview as to how different features vary globally is also provided. Thank you.